Today we've got a double period, so I thought I'd skip, I think it's 1I, yep, 1I, algebra with worded questions. And we're going to do index laws, because this is kind of 2 lessons worth of content. I'm going to cover it all in this video, so it's a bit overwhelming. Remember, you've got an hour 40 to watch through this video of scheduled class time, and then I'll still be around to answer any other questions that you've got. So we're going to start off by looking at kind of what is an index and go from there. So index laws. You'll have seen plenty of these before. You just wouldn't have called them index or indice. You would have used the term squared or cubed and things like that. So let's have a look at this one first. 4 cubed equals. Now it's easy to get the calculator out and type that in. But we're kind of building up some knowledge and some skills, and so we're not going to be using the calculator, and we're also not going to be solving this. We're not after a number in this case. So if you type that into the calculator, you're going to get 64. But when we're exploring what do these look like in expanded form, and then other times we'll be getting them in expanded form and contracting them. So when you see 4 cubed, the tempting thing to do is write 4 times 3. That's not correct, and it sounds really obvious to say it's not correct, but each of us are probably going to make that mistake at some point. What it does mean is 4 times itself 3 times. That little 3 means we're going to be timesing it by itself, and we're going to be doing it 3 times. So a few terms we've got emerging already. This over here is expanded form. And this side over here is index form. And then we're going to label a few things. This is the base. And then this little thing up here has a lot of names, so I'm going to come all the way down here. We could call it the power, the index. If it's plural, we call it indices, which I don't know how to spell. Probably something like that. Power and indices or index. That's enough to go for now. But we'll come across other names. Some of them have special names, like this one, cubed, and if it's a little 2, we call it squared, which we've done a lot with. Now, I'm going to be changing between index form and expanded form for a few of these examples, just to kind of prove laws that then we're going to learn as written laws that we can apply without needing to put it in expanded form. So I like to do this by thinking through an example. Let's have a look at this one. Might be right in expanded form. Let's use the number 4 again. So let's say we've got 4 squared, and I'm going to multiply it by 4 cubed. So to write in expanded form, well, let's start with the 4 squared. That becomes 4 times itself twice. There's 2 4s. And then this one here, 4 cubed, well, there's going to be 3 of them. And here I've got 4 squared times 4 cubed. So I need to do it times. Let's have a go with this one. Let's say we've got 5 to the power of 6 times 5 to the power of 3. So 5 times itself 6 times. 1, 2, 3, 4, 5. They're looking more and more like S's. I'll finish strong. And then 5 cubed. 1, 2, 3. And we got times in between them, because it's all of this multiplied by all of this. Alright, now I'm going to do the opposite. Write the answers from above in index, you might say form or index notation. I'll call that 1 and Roman 2, just so we know what we're referring to. So, here it said 4 squared times 4 cubed. But you notice when I write it out, it's just 4's multiplied by each other, and there are 5 of them. So I can write 4 to the power of 5. There's too many. There we go, Roman 2. Same here, 5 to the power of 6 was all of these 5s. 5 to the power of 3 was all of these 5. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 5s. Now you might be beginning to notice a pattern here. I'll give you a second to pause the video and figure out how I could have saved myself some time. So pause it now and then we'll have a go after that. Alright, so assume we've had a go. Now, you might notice here there were 2 4s, here there were 3 4s because it was 4 squared and 4 cubed. And when I count them all up, it's the same as adding this number and this number. Well, I've got 2 of them, now there's another 3, so I add them together, and I've got 4 to the 5. And the same is true for this one. 5 to the 6 plus 5 to the 3 gives me 5 to the 9. Sorry, times 5 to the 3 gives me 5 to the 9, but I get the index by plussing. Now this only works if the bases, if we go back to our terminology up here, the base number, so in this case 4 or in this case 5, is the same. And we write it officially like this. And I'm going to use the number 2 as my example. I could use algebra and use x, but for whatever reason we save that to year 9. So, index laws 1 and 2. So we'll say 2 to the power of m, so any number, times 2 to the power of n equals 2 to the power of m plus n. I'm going to put in brackets. We don't need to, because it's implied if it's up there in the index that you do it all first. But just to show the grouping, I'm going to do it. 2 times 2 to the power of m times 2 to the power of n means 2 to the power of, add the indices, m plus n. Now division, if you have a go at doing an example in algebraic form, which I'll just do off to the side real quick, I won't spend long on it. Let's say we've got 3 to the power of 5 divided by 3 squared. Remember, you can write this as a fraction. 3 times 3 times 3 times 3 times 3 all over 3 times 3. Well, just like in algebra, we can divide them out if they appear on the top and the bottom. So 3 cancels with that 3. And we're left with just 3 times 3 times 3. And you'll notice if I do 5 minus 2, I get 3. And here, there are 3 3s. So 3 cubed, 5 minus 2 is 3. So it's going to be the same over here. Let's use 5 as our example this time. 5 to the power of m divided by 5 to the power of n equals 5m minus n. And again, I'm putting in brackets, we don't need to, but it's worth a go. Alright, let's do some quick examples there, and then I might stop the video because it's been going a while, and I'll make a second video for the second lesson. So some quick examples. E dot G dot. Let's say I've got 10 to the power of 6 divided by 10 squared. Let's say I've got 4 cubed times 4 to the 4. And let's say 12 to the 8 divided by 12 to the 6 times 12 to the 4. Alright, I want to write each of these in expanded form. So 10 to the power of 6 divided by 10 to the power of 2. I know because the bases are the same that I can use my index laws. That 0 just got worse the more I did it. I'm going to keep going then. I'm going to be using this second one. Now it's really tempting to divide 6 divided by 2. But look at our law. It is m minus n. So 6 minus 2. That gets me a 4. 4 to the 3 times 4 to the 4. So they've got the same base number. So I'm going to be using my 4 here. 3 and 4. Really tempting to times them, but have a look at the index law. M times n gets us m plus n at the end. So 3 plus 4, 4 to the 7. Alright, this one we got a bit going on. So they're all in the same base. So I know I can use my index laws. They've all got 12 as the base. 8 divided by 6, well, that's going to be minus. So 8 minus 6 is 2. 2 plus 4 gets us back up to 6. So 8 divided by 6 is 2. And then 2 plus 4 gives us 6. So we've got 12 to the 6. Alright, have a go at the class kick, and we'll go from there. I'll be hanging around on Zoom because there are some examples that I haven't done. If we ever get stuck, just go to expanded form and then contract it, and it should make sense again. So have a go at that, and I'll be on the class Zoom answering questions.